Hi all, it's my pleasure to welcome you all. Myself, Lakshmi Vishwan, the trainee social worker of Sri Shabarisha College, Kottayam, Kerala. This video is explaining about the tabulation of data, purpose and basis of classification, frequency distribution, construction of frequency tables, etc. Before moving to this topic, we have to understand about the elements of discussion include introduction, tabulation of data, purpose of classification and basis of classification, frequency distribution, construction of frequency distribution or tables, conclusion, reference, etc. First one is introduction. Tabulation of data and frequency distribution are fundamental concepts in statistical analysis that play a crucial role in organizing, summarizing, and interpreting data effectively. Tabulation involves presenting data in a structured format through tables, while frequency distribution categorizes data into intervals or categories along with their corresponding frequencies. These techniques provide a systematic way to analyze data, identify patterns, trends and outliers, and derive meaningful insights that can inform decision-making process. In this discussion, we will delve into the significance of tabulation and frequency distribution in statistical analysis, highlighting their importance in simplifying complex data sets and facilitating data interpretation. And the second one is tabulation. The systematic presentation of numerical data in rows and columns is known as tabulation. Tabulation is designed to make presentation simpler and analysis easier. It aims to provide us much information as possible in the minimum possible space while maintaining the quality and usefulness of the data. Tabulation involves the orderly and systematic presentation of numerical data in the form of designed to elucidate the problems under consideration. And the next is objectives of tabulation. The aim of tabulation is to summarize a large amount of numerical information into a simplest form, and the following are the main objectives of tabulation. First one is to simplify complex data. It reduces the bulk of information, that is, it reduces raw data in a simplified and meaningful form so that it can be easily interpreted by a common man in less time. And the second one is to bring out essential features of data. It brings out the chief or main characteristics of data. It presents facts clearly and precisely without textual explanation. And the third one is to facilitate comparison. The representation of data in rows and columns is helpful in simultaneous detailed comparison on the basis of several parameters. And the fourth one is to facilitate statistical analysis. Table serves as the best source of organized data for statistical analysis. The task of computing average, dispersion, correlation, etc. becomes easier if data is presented in the form of a table. And the last one is to save space. A table presents facts in the better way than the textual form. It saves space without sacrificing the quality and quantity of data. And the next one is components of a table. A table's preparation is an art that requires skilled data handling. Components of data is crucial to understand the components of a good statistical table before constructing one. A table is created when all of these components are put together in a systematic order. In simple terms, a good table should include the following components, and they are table number, title, caption, steps, body of table, unit of measurement, head notes, source notes, and footnotes, etc. And the next slide is include the format of a table, perfect table. This table includes all types of all the components of a table. And this one is a structured format of table with all components. And the next is tabulation of data. Tabulation of data involves organizing and presenting data in a structured table format. And this helps to summarize and analyze the information in a clear or concise manner. The process of tabulation typically involves the following steps. First one is identify variables. Determine the variables or characteristics of interest that you want to include the table. The second one is define categories or groups. Decide on the categories or groups that you want to use to organize the data for each variable. And the third one is count observations. Count the number of observations or data points that fall into each category or group of each variable. And the fourth one is calculate summary statistics. Calculate summary statistics such as totals, variables or averages, percentages or other relevant measures for each category or group. And the fifth one is organize data into a table. Create a table format with rows representing categories or groups and columns representing variables. Input the counts or summary statistics into the appropriate cells of the table. And the sixth one is include labels and titles. Provide clear labels and titles for the table, including variables names, category names, and any additional information needed to interpret the data. And the seventh one is format the table. Format the table to make it visually appealing and easy to read, including using borders, shading, and appropriate fonts. By following these steps of tabulation of data, you can effectively tabulate your data to present it in a structured and informative way for analyzing and interpretation. And the next one is purpose of classification. The purpose of classification in tabulation of data is in several ways, including organizing and summarizing data, facilitating comparison, enhancing understanding, providing structure, and supporting decision making, etc. And the next one is basis of classification. In the tabulation of data, the basis of classification refers to the criteria or characteristics used to group and organize the data into categories or classes. The choice of basis for classification depends on the nature of the data and the specific objectives of the analysis. Some common bases of classification in tabulation of data include qualitative classification. First one is qualitative classification. This type of classification is based on qualitative or non-numerical attributes such as categories, characteristics, or qualities. Examples include gender, marital status, occupation, and type of product. For example, the slide shows the data of the student of class 11 can be classified on qualitative attributes like male or female and commerce or science. The tabular presentation of the same can be shown as the slide. And the second one is quantitative classification. Quantitative classification is based on measurements and numerical values. It involves grouping data into intervals or ranges based on numerical values. Examples include age groups, income brackets, and temperature ranges, etc. For example, data on the number of players playing different sports in a school is shown in the slide. And the third one is temporal classification. Data can be classified based on time-related factors such as years, months, days of the week, or specific time periods. This type of classification is useful for analyzing trends over time. And the fourth one is spatial classification. It involves grouping data into based on geographical locations or spatial dimensions. Examples include countries, regions, cities, or physical attributes like altitude or latitude. And the fifth one is categorical classification. In this type of classification, data is grouped into distinct categories or classes based on specific attributes or characteristics. This type of classification is commonly used for organizing quantitative or the qualitative data. And the sixth one is ordinal classification. Ordinal classification involves arranging data in a specific order or sequence based on a ranking or a hierarchy. Examples include rankings, levels of education, or customer satisfaction ratings, etc. And the seventh one is interval classification. It involves dividing data into equal intervals or ranges based on numerical values. This type of classification is useful for analyzing continuous variables like temperature and time. And the eighth one is hierarchical classification. Hierarchical classification involves organizing data into a hierarchical structure with multiple levels of categories or subcategories. This type of classification is useful for representing complex relationships among different variables. And the next one is frequency distribution. Frequency distribution is a common method used in quantitative analysis to organize and summarize data. It involves grouping data into intervals or categories and then counting the number of observations that fall into each interval. The frequency distribution helps in understanding the distribution of data and identifying patterns or trends within the data set. Here is an example to illustrate how frequency distribution works in quantitative analysis. Suppose we have a data set of exam scores for a class of students 85, 72, 92, 78, 65, 88, 75, 82, 90, 79, 85, 70, 95, 85, 80. In this frequency distribution, the table shows the interval column represents the score ranges and the frequency column shows how many scores fall within each interval. This table provides a clear overview of the distribution of exam scores and can help identify the most common score ranges, outliers, or trends within the data or the set. Frequency distribution can also be visualized using histograms or bar charts, which provide graphical or the representation of data distribution. And the next is construction of frequency table. Constructing a frequency table involves organizing and summarizing data into categories or intervals or in the counting number of observations that fall in with each category. Here are the steps to construct a simple frequency distribution table. First one is identify the variable. Determine the variable you want to analyze and the values it can take. For example, if you are analyzing the age of a group of people, the variable would be age. And the second one is list the values. Make a list of all unique values that the variable can take. For example, if the ages range from 20 to 60, list all individual ages in that range. And the third one is tally the frequencies. Count the number of times each value appears in the dataset. This is known as the frequency of each value. And the fourth one is create the table. Create a table within two columns, one for the values of the variables and one for their corresponding frequencies. List each unique value in the first column and its frequency in the second column. And the fifth one is calculate total frequency. Sum of all the frequencies to get the total number of observations in the data set. And the last two ones are the optional. Add relative frequencies and cumulative frequencies. Sixth one is add relative frequency. If desired, you can calculate and add relative frequencies to the table. Relative frequency is the proportion of observations that fall into each category. And the last option is add cumulative frequency. You can also calculate and add cumulative frequency on the table. Cumulative frequency is the total number of observation up to a certain point in the data set. And moving on to the conclusion, here we discussed about the tabulation of data and frequency distribution and essential tools in quantitative analysis. Incorporating these techniques in statistical analysis enhances the clarity and efficiency of data analysis processes, enabling researchers and analysts to extract valuable information from data sets. Overall, tabulation of data and frequency distribution are fundamental components of statistical analysis that play a crucial role in transforming the raw data into actionable insights. Here, and I referred this topic from these links. And always thank you for watching my video.